Okay, so just to review, yesterday we talked about trigonometry. And so we started off with the Pythagorean theorem where you could find a missing side length. And then we talked about the original three trig ratios, the sine, cosine, and tangent. And then learned that there are three more trig ratios, the cosecant, secant, and the cotangent. So on the back, I am going to go ahead and write our acronym to remember which is which. So it's SOHCAHTOA. And then once you get those three, to find the other three, you just do the reciprocals. All right, so we're going to do pretty much the same thing. The setup is going to be different. Okay, so on this one, it tells you that you're given the ratio for cosine of theta, and we're going to find the remaining ratios. So down here, like where we were writing our answer to the problem, we know that the cosine is going to be is going to be 2 over 3, which that's the ka part of SOHCAHTOA. So what this is telling you is that the adjacent is 2 and the hypotenuse is 3. So what we'll do is draw our own right triangle. What is that noise? All right, so any angle that's not the right angle, you can make that theta. So I'm just going to go ahead and make this one theta. All right, so if that is theta, then this one is going to be the opposite. This is the adjacent, and this is the hypotenuse. And then what they told us, when they told us the cosine of theta is 2/3, they told us that the adjacent is 2 and the hypotenuse is 3.
How are you supposed to figure out where the little O is?
You get to pick where. Are you talking about the angle, the theta? You can either put the theta here or here. It's up to you. I just chose this one for no reason. That's just where I like to put it. All right, so what we need to do to be able to find all of these trig ratios is to figure out this side length. And we learned that yesterday, or we reviewed it yesterday. We're just going to do the Pythagorean theorem. So it's going to be, I'm going to call the missing side, we don't know, A. You can call it B if you want to, it doesn't matter. Plus 2 squared equals 3 squared. How do you know where to put the 2 and where to put the 3 in this? 3 is C. So this one, the opposite of the right angle, is the hypotenuse. We said it was the hypotenuse. The hypotenuse is by itself on the Pythagorean theorem. Okay, and then we just have a couple of steps to figure out what A is. So I'll go ahead and square those numbers. Oh, subtract 4. And find the square root. All right, so A is the square root of 5. All right, so now we can do SOHCAHTOA and figure out all the rest of the trig functions. So remember, sine is the SO part of SOHCAHTOA, where we're going to put the opposite over the hypotenuse. So that's going to be the square root of 5 over 3. And that's it. As long as that square root is on the top, it's fine. It doesn't matter. All right, and then whenever we do the tangent, the TOA part of SOHCAHTOA, we're going to do the opposite over the adjacent. So in this case, it's going to be the square root of 5 over 2. And as long as the square root's on the top, you're done. Now, when the square root is on the top, it makes finding the reciprocals more difficult, but we can still do it. So when I go to do the cosecant, I'm just going to flip over the sign. And because the square root is on the bottom, we do have a little bit of extra work we have to do. Right, so that numerator is 3 square root of 5. And then when I do square root of 5 times the square root of 5, what is that? Just regular 5. Very good. All right. Secant is going to be no big deal because we're just going to flip over 2/3 and that's 3/2 and no square roots to worry about. Right. And then cotangent is going to be a little bit of extra work. So we're going to flip over tangent. And because that square root of 5 is in the denominator, we're going to make sure we multiply by it. And that's it. All right. So they're really not going to get any more difficult than that one. I do have 4 examples here just for some extra practice for you guys with that. If you can do that one, then you can do any of these today. All right. So on the next one, on number 6, we know what the cotangent is. So we're given the cotangent of theta, and we're going to find the rest of them. So the cotangent is square root of 21 over 2. Now, cotangent is the reciprocal of tangent. So that's the TOA part of SOHCAHTOA. So tangent is opposite over adjacent. That means cotangent is adjacent over opposite. And if you look on the other side, we wrote that yesterday. So if you need to look at all the words we wrote out yesterday, you can still flip it over. Okay, so I'm going to draw my right triangle. And I like putting theta at the bottom left corner. Okay. And so I'm still going to, even if you don't need it, I'm still going to do this. Label opposite, adjacent, and hypotenuse. Okay. And according to what they gave us for cotangent, the adjacent is the square root of 21, and the opposite is 2. All right, and so just like yesterday, there is going to be a missing side length that you have to find. And to find it, we're going to do the Pythagorean theorem. So the square root of 21 squared plus 2 squared equals c squared. So remember, hypotenuse is by itself on Pythagorean theorem. And when you square the square root of 21, what do you get? When you square the square root of 21? Just 21. The square gets rid of the square root, and you just have 21. 2 squared is 4. All right, we're going to get that. C is 5 this time. And to find the sine, cosine, tangent, we're just going to do SOHCAHTOA. So for the sine, we'll do the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And then for tangent, it's up to you. We can do the opposite over the adjacent, or we can just flip this one over, flip over the cotangent. It's up to you. Either way, it's going to be 2 over the square root of 21, which means we have an extra step. All right, and then we just have some flipping to do to finish off these last two. All right, any questions? Okay, I'm gonna get you started on number 7, and I'm gonna let you finish it on your own. All right, so what we know on number 7 is that the tangent is 8/15. And if I think of the TOA part of SOHCAHTOA, that means 8 is the opposite and 15 is the adjacent. Okay, to find that missing side length, we're going to do 8 squared plus 15 squared equals c squared. All right, and then if you do 8 squared plus 15 squared, it ends up being 289. And you may not know this, but 289 is a perfect square, and the square root is 17. All right, so you guys finish this one on your own. Okay, so this one's nice because there's no square roots. So when we do SOHCAHTOA, we just do it and we're done. So we just do opposite over hypotenuse, adjacent over hypotenuse, and then just do all the flipping. And that's it. All right, any questions? Okay, this last one it's like the others, like 7 or like 5 and 6, but I just want to do one more with you. It is a secant that we're given, and then secant is the reciprocal of cosine, and cosine is the part of SOHCAHTOA. So what this means is that square root of 73 is the hypotenuse, and 8 is the adjacent. Okay, so then I'm looking for the opposite side. I'm just going to call it A. And then don't forget, when you square 70, the square root of 73 is just regular 73. Alright, so our opposite side should just be 3. Okay, so this one does have a square root, which is going to make it be a little more challenging than the last one we did, but we can do it. So when I go to do the sign, I'm going to do the opposites over the hypotenuse. And because that square root is in the denominator, I am going to multiply by it, which is going to give me 3 square root of 73 over 73. And then something similar happens when I go to do the cosine. It's going to be 8 to the adjacent over the hypotenuse, so 8 over the square root of 73. And then I have that step to do again. All right, and then tangent is just opposite over adjacent, so no square roots to worry about. We're done. Now, this hasn't come up today, but we talked about it yesterday, but it's a lot to remember in 2 days. So when I go to do the cosecant, I don't want to flip over this one. You can, it's just going to be extra work. So I'm going to, when I go to decide what to flip over, I'm going to go back to this purple one where the square root was in the denominator. So when I flip that one, it's going to move the square root to the numerator, which is where I want it. And I don't have any extra work to do after that. All right, and then for cotangent, no big deal. I'll flip over tangent, and that's it.
So what's the difference in what we did today though? What we did yesterday?
Yesterday, the triangle was already drawn, and you found all 6 trig ratios. Today, you're given one of the ratios, and you have to draw a triangle. So it's almost the same. The rules are the same. It's just the setup is a little different. Okay, so yesterday you needed to do the 5 we hadn't already done on the front of the worksheet. And then today you're going to do the back. So if there's still some you hadn't finished on the front, obviously go ahead and see if you can get those done today.